Hello, everyone. My name is Jin Zhang. I'm the Product Management Director at Synopsys, responsible for VC Formal. Today, I'm speaking with Amber Telfer. Amber is a principal engineer at Microsoft, responsible for formal verification usage and methodology for SOC and IP projects. Prior to Microsoft, she's worked at Intel for 15 years, where she helped formally verify the arithmetic unit for Pentium Core first generation. She also used formal property verification tools to verify IP blocks and helped train new formal engineers. Amber got her master's degree in computer science and engineering from Oregon Graduate Institute at OHSU. Welcome, Amber.
Hi, thank you for having me.
So the conversation we're going to have today is about formal performance indicators. When you talked about this at the Synopsys formal special interest group event, I thought this is such a great topic for managers, for design verification managers. So first, please introduce to our audience here, what are formal performance indicators, and give us some examples of what they are.
So formal indicators are any indicator of information that will help tell about progress, quality, information that your team can use to make plans and progress and make decisions, and that your management can use to know where the project is, what the quality is. And so some of those are regressions, how they're doing, bug numbers, tracking of your tasks. So what's the progress along those? And then coverage indicators is also a key piece for formal, even though that indicator means something slightly different for formal than it would be for simulation. So a lot of these probably sound familiar because they're very similar to what you would have for simulation. They just may be collected or express a slightly different information, since formal verification approach is different in its application and scope than simulation approaches.
Talking about the differences between formal and simulation, maybe use coverage as one example to tell the audience here what the differences are. And also, most importantly, why are we doing this? Why are you tracking this? What's the benefit that you've seen tracking those indicators?
Coverage is the one that is the most different. And for simulation, when you're collecting coverage, you're really trying to see what your stimulus is. So if you're not creating the right stimulus, then your coverage will be low because then you're not checking the right things. Where in formal verification, we naturally get all of the stimulus we need, unless the interface is missing something. And instead, the coverage is actually telling you the quality of your checking. So it's actually showing what are the properties that you have written and are running actually covering in the design. So it's a different perspective, kind of inverted. The benefit of these indicators, so there's twofold. One, it can be for your individual team as you're actually doing the work. It can help you guide to see what's missing. And if you have big gaps or small gaps, because every time you add new properties, you will see a change in your coverage numbers if you're collecting them on a regular basis. Whereas for the higher level, managers and project leads want to know how close you are to being done. And so coverage indication is one part of that can show how close are you to covering all the possible functionality of the unit that you're verifying.
Yeah, that's why I really loved what you presented, because formal always seemed to be very different from simulation. And sometimes it's hard for management to understand what has been done and what's the progress that has been made. And through your indicators, I think it's in a very familiar form for them to be informed about the benefit and also really the progress, and also for them to maybe invest more in formal, right? Seeing the progress you made and the bugs that's caught with formal. Now, in your journey of trying to set it up, what are some of the lessons you learned or advice that you can give into teams who are trying to set something up similarly?
So setting it up, you shouldn't start from scratch. That's the first thing, is that you probably already are collecting information and data that you haven't really thought about being indicators. So if you have, if you're tracking your work in a spreadsheet, in ADO tickets, in some other system, you have that information. If you're filing bugs, you have that data. And so leverage that and just extract that data and put it into a indicator friendly display. So a chart or something that management can see the changes over time or the summary of progress. Other indicators, you're going to have to do some work to make available. And the key to this, I really believe, is automation. So if you can automate the collection, then it is really easy to bring up the indicators based on that data. And the effort of having a individual engineer spend their time to collect that data every time you need it is costly, and also makes people not want to even collect the indicators because of the additional work. But you can easily bring up those indicators on a moment's notice if the data has already been collected, because the chart generation steps are actually the easiest piece of this.
And I just have like to say that I really love the charts that you showed at our conference, and that really shows the power of formal verification. When it shows the number of bugs that you can catch a lot of times much earlier than simulation effort. So really great job in that, and thank you so much for sharing with our audience about your journey tracking formal indicators and the benefit that management will see from this process. For our audience out there, if you want more information, check out Synopsys website, and we'll see you next time. Thank you so much, Amber.